So thank you everyone for joining. First questions about CTERA, about who we are, what we do, and then move forward with our webinar for today. So CTERA Networks. So CTERA is a startup company that was founded back in 2008, and our mission was to primarily enable enterprises and service providers to deploy secure end-user data services and of course choosing their own infrastructure to do so, meaning choosing the storage layer, the virtualization, and all of the other components as well. So they are very flexible in terms of their infrastructure, and they can enjoy the breadth of data services that we can enable them with. So a little bit background about our experience and about the founders of the company. CTERA was founded by people that were formerly employed in a company called Software that was at a certain point acquired by Checkpoint. So most of these companies' founders come from a vast experience in the security and networking area. This is a key driver in our platform and software development, and this topic is very much emphasized in all of the our software development and the product itself. So let me introduce myself. My name is Simon Michelson, as Jeff mentioned, and I'm product manager in CTERA Networks. I joined CTERA back in January 2011. Been working for the company for almost 4.5 years now. Held several positions in the company, from development, sales engineering, and most recently, about a year and a half ago, joined the product management team. And for today's session, we'll be discussing primarily and touching the main points that might be taken for granted today and maybe overlooked. These are key topics that need to be considered when choosing your cloud services for hosting your enterprise storage or data. Of course, this is only a tip of the iceberg in terms of the amount of security risks, threats that exist out there. But these are the primary ones that I think is worth to thoroughly discuss today and understand the risks and how, of course, you can defend against those risks. So we'll go ahead and start with the first topic for today, and that's understanding what real source-based encryption means. So today's encryption is a word that is used widely and is thrown out there in every article, and almost everybody today mentioned that they encrypt the data with many layers, but we should get a very good understanding of how most cloud services do it today, and what are the risks of using this type of behavior or workflow to encrypt your data. So let's start with the simplest approach. With the most simple approach is that there aren't any encryption schemes incorporated to the cloud service that we chose to host our entire enterprise data service. So for this illustration, we will use a text file called the quick brown fox. So looking at the diagram on top, and we have an insecure channel, which is completely clear. There's no encryption in it, and any file that I choose to upload or synchronize to my cloud service is sent in clear, and of course stored clear in the underlying storage of that particular cloud service. I'm sure it's very clear to everyone that this setup is the worst setup that can be. Of course, there are many points where this particular file can be compromised by attackers, and this is of course while the file is being uploaded or synchronized through the secure channel, or of course in case attackers, for instance, hack into the cloud service storage and they're able to grab the file directly from there. Of course, but we can do, of course, a little bit better, and we can choose to encrypt the data with TLS protocol, the Transport Layer Security. So we can take the quick brown fox and encrypt it with TLS. So this means that when the data is being fired away from our PC, it runs through a secure channel. However, at a certain point, when the data arrives at the web service of the cloud service that we chose, the data, of course, gets decrypted. So the SSL or TLS layer that was applied on top of the quick brown fox is then being decrypted. So at a certain point, we reveal back the file in clear, and then, of course, we can store it this way on the cloud service that we chose. This is another way. This is another way to perform to secure our data, of course. However, if we cannot hijack the data while it's being transmitted over the network, we can still access the data on the cloud service and grab it from there in case of an attack. And let's speak about what most or the well-known cloud services or SaaS services do today. Okay, so what they will do, in essence, will be to encrypt the channel using TLS, and then send the data over the wire. At a certain point, as mentioned previously, that SSL or TLS layer will be taken off from our file or specific block that we synchronize to our cloud service, and we reveal the file in clear again. One thing that is important to mention here is that by decrypting the data at this stage, we have this particular space or area where data can be compromised. So we have this red line that we can see over here, and this red line transmits the data in clear, and so potentially attackers can perform, for instance, man-in-the-middle attack, where they tap in to this particular area in the application, either on Box, Dropbox, for instance, or on the network level, and then grab and steal the file at that point. Now, what most SaaS companies will do at this stage is that they will also encrypt the data at rest. This means that they will generate a key on the cloud and then encrypt the data with AES 256 and then store the data this way on their cloud. So potentially, of course, protecting the case where attackers will directly access the cloud service and attempt to get the files from there. So with this security mechanism, they won't be able to, of course, access the data from the cloud. However, there is a certain point in the file's path where the data is sent clear, and is, of course, a vulnerability for that can be exploited by attackers. So we can all agree that this particular channel is a point where we cannot compromise in security in terms of how we see it in CTERA. So we therefore incorporated to our solution a different way to further protect the data that we send and synchronize to the cloud. So let's see how CTERA does this and how CTERA is able to defend this particular gap where the data is transmitted in clear mode. So what CTERA will do is first encrypt the data with AES 256 encryption at the source, and the source meaning my employee's PC. And then on top of it, we will also encrypt it again with TLS, so that when data is sent over the wire, is sent over TLS. And at a certain point, when we take off the TLS layer from the file, we still get a file which is encrypted with AES 256. And we use this file and store it this way on CTERA. Okay. So you can see that in this setup, we have 2 layers of security. This means the data is never transmitted in clear mode from the source to its destination, and we can always ensure that an attacker won't be able to hijack our files on the network, and also when the file is stored on our underlying storage system in our cloud. Okay, good. This was source-based encryption, and moving forward to our next topic for today, which is data integrity and how you can protect and ensure that the data you uploaded to your cloud service is in fact wasn't tampered or destroyed in a certain way. So in order to do that, we need to do some preparations and gain some knowledge about what we call fingerprinting, which is a mechanism that you can use to apply certain security measures to your system. So this is Paul, for instance, and Paul is uniquely identified using his biometric fingerprint. Okay, this is Paul's fingerprint, and whenever he goes to the airport, he can just place his hand and immediately get a ticket to move on to the next station before he departs his plane. And this particular fingerprint will allow us to always identify Paul uniquely whenever we want to. So taking this analogy and applying it to computer science, we can think of an AES 256 encrypted file, which represents the quick brown fox PDF. And luckily for us, computer scientists have invented functions that are called one-way hash functions. And those functions provide us with the ability to create a digest or a string that basically uniquely represents this particular file, or encrypted file, of course. So in essence, we can have some sort of a computer program or software, a piece of software that receives as an input an encrypted file and outputs a string that represents it uniquely. Okay. Once we gain this knowledge, let's see how we can apply this as a security measure, and what are the risks of not using this approach that is vastly today exists with among cloud services today. So we have the quick brown fox on the top left. We first encrypt it with TLS and send it over the wire. And as we mentioned previously, we take off the TLS layer and reveal the file in clear again. And at a certain point, an attacker at this stage will be able to perform a man-in-the-middle attack and change our file into some sort of malicious software or a virus, for instance, or a Trojan horse or a worm file. So upon transmitting the data over the network, we then get different data stored on our cloud service, and that malicious data or virus is then encrypted with an AES 256 key and stored this way in the cloud. And the risk of doing that is actually the follows. So imagine that you delete the file from your PC, or go to the web interface of your cloud service and download the file from the web interface. What will happen is that you will actually download a virus or certain program that will be able to take over your corporate PC and then, of course, expand and compromise other corporate PCs and this way hack to the intellectual property of your organization. Okay. Now, another way to compromise the data is not only by when running through with a man-in-the-middle attack during the file while the file is being transmitted over the wire. Another way to do it is, of course, to tamper the file while it's I'm sorry, to tamper the file while it's encrypted on your cloud service. So an attacker can potentially, of course, access the underlying storage connected to your cloud service and then compromise the file. Either by, of course, this attack can be conducted by an evil employee of the cloud service that you chose, or, of course, an attacker that was able to obtain a key that allows him to decrypt the data on your cloud storage, and then, of course, alter the data in a way that changes a scheme to a certain virus, again, a malicious software, and so on. And this way, of course, inject bad software to your corporate PCs. So once we understood this type of attack, let's see how CTERA is able to defend against such an attack. So again, with CTERA, we encrypt the data twice, first with AES and then with TLS, as we saw previously. Then we send the data again over the wire where we take off the TLS. And then we have an AES 256 encryption file that is stored on our backend storage connected to our CTERA portal. At this stage, what we'll do is that both the client and the CTERA service will calculate the hash function or the digest that uniquely identifies this particular file, as we can see here. So we have a string on the server side, on the right, on the cloud, and we have the same string on the left. And we will compare those fingerprints to ensure that the data we sent over the network was transmitted successfully and stored on the cloud service. In case the data was tampered, of course, if we recall previously, an attacker can potentially access my storage in a certain way and change, destroy certain blocks of my files or wipe out or tamper specific ones. So in case the files were compromised, we will get a different fingerprint for that particular file. And in case that happens, we will, of course, throw away the file and retransmit it again to the cloud service. And then, of course, we will again compare the fingerprints to ensure that the data arrived successfully. So what we saw here is two different attack vectors for when uploading data or synchronizing data to your choice of cloud service, and the importance of ensuring that the data arrive safely to its destination. This is an example of a validation scheme that is not implemented today with most of the cloud service companies, SaaS companies, and it creates a lot of risks when we speak about sensitive data or corporate data that can be compromised, and of course malicious software that can spread in our organization and then of course compromise our intellectual property. Now, on top of it, CTERA applies certain security enhancements to even make the security of the data, ensuring your data integrity in this case, there are additional enhanced features in that area as well. So in order to outline them, we need a little more knowledge, and specifically about certificates and what certificates are and what are the main benefits of using a certificate. So this illustration aims to simply explain what our certificates are for. And the main idea for certificates is to ensure that the website we are accessing to is in fact who he says he is. Because potentially this website can be compromised, and I can launch my own version of Dropbox or Inbox and impersonate to that cloud service, and users will never notice, and potentially all of the files that they choose to sync and upload to my system to the system will go through my evil website, and I'll be able to see everything that they have on their PCs. So in order to secure and ensure that I'm in fact accessing the website that I trust and know, this is for instance, my bank account. Certificates are handled in the following way. We have Mark and we have Paul, and Mark is the user trying to access the web service, and Mark is set to trust Paul. Paul is an entity that is trusted by both Paul and the cloud service, and he generates a certificate for website.com, and this certificate says that Paul certifies this website and claims that this website is in fact who he says he is. So Paul is generating this certificate and sends it over to the website. The website then uploads this certificate to his web service, and using the security terminology, in that case Paul is called the certification authority because he's the one generating the certificates and distributing them to the websites that want to use TLS encryption. So when Mark then attempts to access www.website.com, he will then see that that particular website has a certificate, and that certificate was issued by Paul. And since Mark trusts Paul with this transitive relation, he then trusts this website. And what we can see as the user, as the feedback that we can see as a user, for instance, on our browser, we can see the green HTTPS, for instance, when we browse to the web through the web interface. But of course, the certificate has other responsibilities apart from ensuring our secure access through the web interface, but also to encrypt and generate the secure TLS channel that we saw previously. So the same green channel that we can see here is being created using the certificate that is uploaded to the cloud service that we are browsing to. So when choosing, for instance, a cloud service, companies such as Dropbox, Box, they all have a single certificate that serves all of the users and companies using the service. So in essence, that cloud service company will go to their certification authority and generate a certificate for their website and load it to their website. Now this may pose a risk to companies and enterprises choosing to go with a cloud service for storing their data. And this is since if this particular certificate is being compromised by any attacker, this means that not only Alice's data is being compromised, but also all of the enterprises or companies that are using the same cloud service will be compromised as well, because by compromising the certificate, a hacker or an attacker would be able to read and decrypt anything that is transmitted on the TLS network pipe that we can see here. So any file you synchronize and upload can be hijacked, and attackers can take a look into the file. They can alter it, they can steal it, they can do basically anything they want to do with it. Now, in CTERA's case, since our deployment model is deployed as a platform, and we're very flexible, and we don't have a single shared hosting environment, we support dedicated or customer managed certificates. This means that by deploying CTERA, a customer can issue its own certificate signed by a well-known certification authority that companies such as GoDaddy, VeriSign, Taute, and so on. But of course, we also support the option of issuing privately issued certificates. So certain enterprises or security-conscious companies, mostly companies operating in healthcare, financial, insurance, and so on, they're likely also to have their own certification authority that issues those kinds of certificates, because any type of equipment or storage service needs to be secured and trusted by the enterprise PCs. So in that case, our platform also supports those private certificates, so you can ensure another layer of security and data integrity, and of course avoid and defend against those kind of attacks that exists out there. Okay. Our next topic for today would be enterprise key management, and this is a very hot topic these days, as means to provide enterprises with the control to on their encryption keys, and of course push them into adopting shared cloud services. So the first thing that we'll do is we'll try to explain very simply how enterprise key management works, and then we will specifically discuss the risks and the threats that exists in this particular setup. So how does it work? So let's take the simple use case today for how you synchronize or upload new data to your cloud service while using a key server to encrypt all of the data that is stored on the cloud. Just as a short background about the key server, the key server is as it states, is a server that holds encryption keys, and by connecting your data service with a key server, you can ensure that all of the data is encrypted with your keys, of course, and at any certain point you can of course disable the access on your key server, and this way disallow users from or of course also attackers from accessing the files. So let's take the use case of uploading new data to the cloud. So we have our quick brown fox, which is encrypted with TLS and then transmitted over the wire. At a certain point, the TLS is being scraped off the file, and we reveal again the file in clear. Of course, one point to mention here is that the file is revealed in clear, but not necessarily running through clear on a network line. The file can be decrypted in the memory of the cloud service that you are using. So after uploading the file the cloud service will then generate an encryption key and then use that encryption key to encrypt your file. The cloud service will then take the encryption key and send it over to the key server that's owned by you, by the enterprise, and in turn, that key server will return a different key, the red key, which is the red key actually represents the green key encrypted with a customer managed key, the yellow one that we can see here, for instance. And now the red key is sent back over to the cloud service and stored over there, so that when you attempt to download the file, the same file back, what will happen is that the red key will be sent out to the key server, and in turn it will output the original key that was used to encrypt the file. The green key will then go back to the cloud service, decrypt the file, and then run over transmit it on the secure channel and go back to your enterprise where it will be decrypted again. So this is a simple explanation on how the enterprise key management setup is working. So now let's examine the risks and the threats that exist out there in this particular setup. So first thing that we don't have control over is in case someone is, of course, tapping or logging all of the green keys, the keys that we use to encrypt the data. So imagine you're using a cloud service, and of course that cloud service was issued with a subpoena or taken over by a government department or facility, and was forced to deploy a recording device that taps into all of the encryption keys that were generated by your cloud service. So in essence, what will happen is that all of the green keys that you generated in order to encrypt any file that was uploaded from your corporate will be stored in a safe deposit box held by the government institution or the company that has taken over the cloud service. Of course, it can be, of course, not necessarily a government institution, but also an attacker or a hacker, basically. They can use a vulnerability that, in order to inject software that taps into all of the encryption keys that are generated for the files, so they can use them, of course, at any point to decrypt the data that resides on your cloud service. The next risk in this particular setup is, of course, the fact that decryption and encryption and this engine is basically held in the memory or the compute nodes of the cloud service that you chose. So what we can see here is that we have the file in clear mode on our data center, and the file is being encrypted with the green key. At this stage, for the encryption phase, we have our memory components and our CPU components in the servers that are actually running the cloud service, and in that case, those servers store temporarily, of course, the encryption keys to encrypt the clear data. And this poses, of course, a very large threat. And I think the best example to illustrate that is with the Halbleed vulnerability or an attack that was recently found. So the Halbleed attack is an example of vulnerability that existed in the TLS protocol, which generally allowed attackers and or insiders, of course, to exploit vulnerability in the TLS and grab a certain portion of the memory of a server. So in essence, by sending a specific type of data to your web service, will then respond with a portion of the memory at that specific time for that particular server. So imagine if you had your encryption key at that time uh, in the memory of your cloud service. So an attacker can potentially, of course, grab portions of the memory of the cloud service and then construct a database basically with all of the encryption keys that were used to encrypt your highly sensitive data. In addition to that, of course, not only attackers can compromise the security of our system, of course, we can also have insiders. There are many famous attacks for what we call evil employees. Or employees that, for instance, were fired and they hold some inside intel about where are the encryption keys stored and so on. So those insiders can, of course, also obtain the encryption keys, those green keys, and use them to access your highly sensitive data. And the third risk for the enterprise key management setup is, of course, being able to impersonate to any one of the users that we have in our cloud service. Since this is, of course, an application, and as the cloud service launching the service for you, I can impersonate to any one of the user accounts that you have in the system. So we could have potentially those users and impersonate to them as the admin or any of course vendor that is launching the cloud service, and I can use those users in order to generate links. I can collaborate this sensitive data and of course download it. What will happen is that I have no way, as the enterprise or the corporate using the cloud service, I have no idea of, there's no way for me to identify this type of access as a non-legitimate access. This is, of course, since it was done on behalf of one of my users, or, of course, after impersonating to that to one of my enterprise users, I generated a link to specific content of that user and then accessed it as an external user. Okay, and now understanding how CTERA defends against this kind of attacks and of course setups. So this is primarily relates to the CTERA's deployment model. So what we have here on the right is that we have our cloud service and we have our enterprise on the bottom left corner. So what we can do is speak about a little bit about how CTERA's platform is deployed. So CTERA is first of all a platform. So this means that you can choose your own virtualization and your own storage stack and deploy our software on that particular stack. So you ensure multiple things by doing this way. So first of all, if you have your own private cloud, which exists in your enterprise and you have full control over it, first of all, you gain the two encryption layers that you can see here that were previously mentioned when we discussed about the source-based encryption. And we have everything basically stored on-premise. So this is an example of pure private deployment that CTERA enables. So we have our private cloud and we have our encrypted data stored in our private cloud along with the encryption keys and of course the engine that is responsible for performing the actual encryption and decryption of the data. So in this particular model, of course I have full control of the data and I can, for instance, government institutions and hackers cannot take over my facility and ask me to install tapping device to record all of my encryption keys. I also have the authentication piece inside, so I cannot impersonate to any of my users. And very important thing to mention here is that CTERA does not have any access to your platform as the vendor providing the software. So this platform is pure private, and we never have access to the data. It's purely managed 100% behind your firewall, and you have full control on the system and of course in who accesses the system, and of course ensuring it's done in a secure way. But of course this type of model is one of the models that can be accommodated with our solution, and another model is the hybrid model that you can use and basically offload your actual encrypted data to the cloud. So it's okay to, of course, adopt the cloud. And it's very important to, but it's very important to understand how to adopt it in a secure way that will ensure that I won't be, of course, compromising my enterprise data. So in this model that we can see here, we have our encrypted data stored on a public cloud. However, the actual encryption keys and the engine and that is responsible for doing the actual encryption and decryption of the data is held private. So this means that whenever users want to download the data will be fetched, encrypted from the cloud, and then our engine will be responsible to decrypt the data and hand it over to the user that requested it. Of course, the encryption keys themselves also held private. So this means that in this particular model, an attacker, in case an attacker accesses the public cloud and is able to view or download the encrypted data, he won't be able to do anything with it. And in addition to that, he won't be able to use, for instance, the vulnerabilities in the SSL and so on. And this way, of course, he won't be able to obtain the actual keys from our platform. This is since even if the keys are stored in clear temporarily in the memory for the time that we decrypt or encrypt the file, but of course this component is held purely private in contrast to the previous setups that we saw previously, where the actual engine and the encryption keys were managed on a public and shared cloud service. Okay. Moving forward to our next topic for today, which is metadata and user identities. This is also a very important topic as a primary building block that we should address when we decide to adopt data service, as it may create a lot of risk and threats to our company's intellectual property and its security. So what is metadata? In a nutshell, basically. So the metadata is the data about our data, and you can think of metadata in this way. So we have 3 safes, and we have one safe storing dog food, another one storing golden bricks, and another one storing chocolates. And you can think of metadata as tags. So simply labelizing or pasting tags on top of our safes, saying that this is dog food, and we have 10 pounds of it. We have 32 bricks of gold, and we have Hershey's chocolate in the 3rd safe. And now it's very important to understand the risk of storing the metadata as a cloud component. Storing the metadata as a cloud component is basically having a safe with a list on the safe that outlines the contents of that safe. So imagine you had a piece of paper on your safe that stores the golden bricks, and you have this paper describes all of the contents that you have over there. This can, of course, pose a very large threat to our enterprise, because if, for instance, a burglar came into my house and he saw 3 safes with those kind of tags, he will then, of course, invest all of his efforts into hacking or compromising this particular safe. So let's reflect that into how it works with public or cloud data services. And in our enterprise, we have our safe, including our golden bricks, which is represents our intellectual property. But we store a cloud component, including the names of the files, their size, who owns them, and who recently modified them. So these are this is an example of tags that we can that are commonly used by cloud service companies that store metadata as a cloud component. And of course, there are many others. So what we can see here that, for instance, if an attacker comes in and compromises the metadata that exists in the cloud, he gains a lot of insight of what type of data is being held in my company. So sometimes even knowing the data about our data is more critical, or as critical as obtaining the data itself. So, for instance, in this model, I can determine that this company has a database of credit cards that weighs 100 gigabytes. That's a lot of credit cards, and this sounds like a very good target for hacking and investing my efforts into obtaining this information and hacking to the systems of that enterprise. So this, of course, poses a very large threat, and which should be also taken under consideration when you choose your choice of cloud service. Of course, but we can take it also to another direction. So if it's not credit cards, a credit card database, but we can also learn a lot from other types of files that we have, right? So files such as resignation letters. So I can gain a lot of insight to the contents of the file by simply getting the metadata tag of its name and who owns it, of course, and when was this last modified. So imagine you have a file that it's called taking over the company, how to take over the company in 10 steps. This can be a very sensitive data that you want to be, of course, you want this data to be protected, and make sure in case an attacker or, of course, a company employee is able to hack this kind of data, he won't be able to understand what type of data we have in our company. The next component that is very important to secure and is widely exploited today, and is a very hot target for attackers today, and these are user identities or in specific user authentication. So we can hear about these type of breaches almost every day. I can share some statistics with you that from January 2015, there was about approximately around 350 identity thefts and breaches, and each breach was compromised about 100 to 10,000 of user identities, passwords, credit cards, and so on. And now, the risk of course, storing the user identities as a cloud component is first of all because I'm sure we can all agree that The majority of our users either do the following. Either they have a single password that they use for any type of app they have, whether it's a personal app or a cloud application, for instance, or whether it's an on-prem enterprise application. So there are many apps. For instance, if you take SharePoint, we take Salesforce, we take I'm sorry, SharePoint, Salesforce, Hyper-V servers, and so on. And by using the same password for every application, which is widely done today by many users, potentially compromising the password will then give the attacker the option to then hack into other systems as well. In addition to that, apart from, of course, being able to hack to all of those systems, is that, of course, by obtaining the user identities, you can, of course, hack the private data service or cloud service that was deployed by the enterprise. So if we take this model, for instance, and this model represents a setup where we have our metadata, encryption keys, encryption engine, and also the data on premises, protected by the enterprise. However, the user accounts exists in the cloud. So potentially an attacker, by compromising those user identities, he can impersonate to any one of them and use them in order to access my highly sensitive data, and of course use the username and password to access other enterprise applications that I have in my company. Our next and the final topic for today is using network countermeasures and how you can apply a network security layer on top of the application security layer. So today, when using public clouds, we have a very large attack surface. Public clouds, by their name, they're public, so they're available for everyone to use, and we cannot apply a lot of security countermeasures in the network level. This means that we have potentially a lot more attackers to defend from, and this, of course, increases the potential of being able to access our public cloud service. Of course, we want to have better security than that. Okay, so application security can be applied both on the public and the private cloud. But when using a private cloud deployment model or a virtual private cloud, you also gain access to the network components, right? Because you own the load balancer and you own the firewalls and so on. And of course, you have the best knowledge of how your enterprise works in terms of what kind of traffic is acceptable, what kind of ports, what types of sources are allowed to access the system, and using your knowledge about your enterprise behavior and patterns, or user usage patterns, and also network patterns, you can apply an even better security layer by utilizing your network countermeasures to further strengthen your data protection. Okay. And now, to summarize and to have a deeper understanding of what the cloud is, to be honest, I mean, from my experience, I have trouble to explain this term to my folks. They still think clouds are floating in the atmosphere. But a effectively of what's being deployed today, a cloud is actually represents a bunch of a centralized data center that holds a lot of servers. And our servers in our data center can have multiple roles, and we can have servers for compute, storage, networking, and encryption keys, and basically we can our service is comprised of multiple servers and multiple components that all of them together build our cloud data service. And the main risk of using a cloud service in this case is, of course, we need to understand that we are running on a shared environment. Although this may even seem to us as a new virtual instance or a tenant or and so on, however, we share the same hardware and we share the same servers. So if we take a bank, for instance, and this bank is choosing a public cloud service, and all of the data and highly sensitive data is being sent out to and hosted on this public cloud service. So this bank is, of course, segregated between different servers according to their specific role. So we have a compute node, a portion of the compute node that is set to handle all of the load generated by the bank, and we have a dedicated container for the bank encryption keys, his storage, and so on. But of course, we have no idea of knowing who is sharing the same hardware with us. So it can be even a hacker or an evil company or any type of company with bad intentions, and we have no way of controlling that particular piece in our deployment model because it's a pure shared environment. And the main risk in this kind of setup is that, of course, all of the nodes are interconnected between them, and we have data flying between different servers, and we have encryption keys running to compute nodes and storage running through network and so on. And so inherently in this type of model, data is leaked, or potentially can be leaked from the hacker to the bank. So, for instance, a hacker uploads a virus or a malicious software that is being leaked to the storage layer of the bank, and then in some way downloaded by one of the bank's users, and then spreads in the corporate PCs. Or the other way around, of course, if we have highly sensitive data stored in the bank storage, that is being inherently, of course, sent over to one of the containers of the hacker. So this type of model doesn't give us much flexibility in the underlying storage or the underlying hardware, and this is a major point that needs to be addressed, and currently it's being somewhat overlooked due to, of course, all of the abstraction layers that we have today, that we abstract the hardware with virtualization and so on. And this actually creates some sort of an illusion, or reduces our importance to that, to the way that we attach importance to this particular topic, which should be also addressed when we choose to deploy our cloud storage services. So to summarize our session for today and what we had, and what are the primary components that we should secure. So we saw mainly 5 topics, or maybe even 6. We saw what real source-based encryption is. How can we ensure that data is never sent in clear or in plain text in any way of its life cycle, ensuring that data is always encrypted at the transmission layer, the networking, and also on the application layer. Unfortunately today, one of the main vulnerabilities of public cloud services is that the keys and the data is stored in clear for a short or maybe even long period of the life cycle of that file when it's uploaded or downloaded. We show how we can improve the data integrity and make sure the data is not tampered or being attacked or stolen from our network and transmission lines by using fingerprints to ensure that the data that we sent over was in fact arrived to its destination. We covered the topic of encryption keys and saw the different threats of implementing a solution using a key server, either if it's a public component or a private component. We saw vulnerabilities such as tapping devices that log all of the encryption keys that were generated by the cloud service. We saw an attack of impersonation, where we impersonate one of the user accounts and on their behalf generate links or download the data without any way of the enterprise knowing that. And we saw, of course, an attack of stealing the user's metadata and user identities. So potentially, of course, stealing the metadata and the user identities can give us a lot of information about what kind of data is being stored in the enterprise and whether it's and qualify that whether it's a target for pursuing an attack. So essentially, hackers can use metadata to determine whether this type of content is worthwhile to go for. And of course, compromising the user identities will allow them to impersonate to any one of them, access any type of enterprise application I have deployed, and of course, access my user's data. And the last topic that we covered is using the network as a countermeasure for strengthening the security of our choice of cloud service. So as we saw today, we don't have control over this component when choosing to go with a public cloud service, this type of component is very important as it can allow us to dramatically reduce the amount of attacks, since we can block the majority of them in the network layer, or of course even all of them. And as the IT administrator or the CTO that is in charge of deploying the cloud storage service, you're the one that is mostly knowledgeable about what kind of patterns and network patterns that you're accustomed to in your enterprise. So you can use your knowledge to even apply a strict network policy to ensure the data is always secure. Okay. With that, I would like to thank everyone for joining the session. I'll be happy to answer, of course, any questions you may have. But with that, these are the primary building blocks that should be protected, and you should not overlook them when you examine the cloud service of your choice.
Thanks, Simon. It's actually funny. This discussion reminds me of the hack that they just did on Sony, if you remember that some months ago, where
yes,
the primary folder that they ended up discovering, that the hackers ended up discovering, which ultimately resulted in the massive data breach, was the folder's title was passwords. and once they got that, it was pretty much open season on all of Sony's data. So
Absolutely.
probably a lesson in renaming your folders too. Okay, so there's some questions here. First participant asks, can you explain in more detail how a virtual private cloud is different than using a public cloud provider?
Absolutely. So it's a very good question, and we did not cover the virtual private deployment model in this particular presentation, and of course it's a very encouraged model to use. So as we maybe even touched a little bit about this topic when we discussed about the network countermeasures. So and a very good example of the benefits of using virtual private in this case is that it also enables you with the option of controlling the network components and applying a very strict network policy, so you have full control on the firewall, on the VPN access, so you can tailor a dedicated VPN line between your enterprise and directly to the virtual private you're hosting on your choice of public cloud, public infrastructure. So you can also apply a lot of security constraints and strengthen the overall security of the system by using this type of layer. So in essence, virtual private cloud gives you extended control on your deployment model. So this, of course, control is fully available when you go with a fully private model. But if we take the public case where you don't have any control on the infrastructure, on the servers, and you know the environment, as we explained, it's a shared environment by default, as it's maintained, of course. So the VPC, the virtual private cloud, gives you the control also on that layer, on the infrastructure layer, so you can also secure that layer when you deploy the service.
Okay, thanks. We have a few other questions, but as far as I can tell, they were mostly answered through the course of your presentation. So, considering that we're already about 10 minutes over the session today, I'm going to say let's call this one a day. And Simon, I want to thank you again for taking the time to prepare the discussion as well as to deliver it today. I think it's a really topical conversation that needs to be had right now, and I think you helped put some things in a new light relative to how they're talked about otherwise in the marketplace. So thanks so much, Simon, and thanks everybody for joining today in our Cloud Chat session around security.